Alright, welcome to the third video in this tutorial series, creating a workflow from Rhino into Unity 3D. And so we've arrived at this point where we have a textured model in Unity 3D, but it's still far from convincing as we don't have any lighting set. So the easiest way to start working on the environment is to add a skybox, but we can't do that yet because we don't have the correct camera in the scene. You see in our layer hierarchy, we currently have the Carpenter Center as a 3D model, which contains all this geometry, and we have what's called a main camera. We could put a skybox on this camera, but we're going to need to delete it and bind a camera to a character. So let's just go ahead and do that. So we now only have the Carpenter 3D model in our hierarchy. Let's go to, if we go to all prefabs in the favorites here, we see we have a third person and a first person. And we're just going to use this first person character controller. We can just drag and drop that anywhere into the Unity scene. Somewhere there is fine. Let's go ahead and position this guy to be in a decent starting place. So it's this kind of pill-shaped, capsule-shaped geometry which represents human form. And we can try to make sure he's about the right height. Put him about that high off of the ground plane. And he should be, in this case, approximately the right size. We can change parameters here later if you want to adjust the character motion script in terms of the acceleration, velocity. Changing these around a bit can help give the simulation a feel of being not the out-of-the-box Unity default. So it's probably worth your time just to experiment and change these parameters a bit. So next up, we need to add a skybox, which is just a kind of a fisheye sky view that will be applied to the entire scene. There's a couple different ways to do this, but I find the best way is to go to Edit, Render Settings, and then here there's a number of parameters we can change. Let's just set the skybox, click here, and I'm going to set it to Eerie. This is just one of the skyboxes that ships in the Unity 3D defaults. If you want something a bit more special, you can check the asset store. You can make your own skybox. Okay, so that's applied. If we click Effects, that applies it in the scene as well. And it's now been applied in the game. So the game is looking super dark. We can change the ambient light to be a little bit brighter, but what we really need to do is start adding lights into the scene. So lighting is probably the most difficult part of creating a Unity scene. And there are a number of different strategies you can take, and it depends a lot on the nature of your geometry, whether it's interior, exterior, or both. Of course, it's more difficult to illuminate a scene that has both interior and exterior components. But my general strategy is that we're going to first create the ambient lighting and what's referred to as global illumination. What we can do specifically in Unity is called light mapping, which is an ambient occlusion method, which is a rough approximation of global illumination. When Unity 5 comes out, it's supposed to have much better global illumination in real time. But since we don't have the means to process this now, we basically need to bake a global illumination, kind of the overall general light settings for the scene. So that'll be step one, is kind of baking this global illumination. And then step two is kind of adding in the accent lights or just kind of more detailed lighting in particular parts of the model. So let's start with the light mapping, or the baking of the light maps for the scene. In order to do that, we're going to need some lighting already in the scene. and I'm going to do just one additional light. So I'm going to make a directional light to kind of simulate the sun, but the sun is kind of going down. It's not going to be a very strong light, but it'll help add some realism to the scene. So if we go to first game object, create other, or we can create empty first, and just rename this lights. So we're just going to make a tree under which we can put all of our lights, and then decide whether or not to turn them on or off. Again, just keeping things organized here. Then if we go to game object, create other directional light. So that threw a directional light into the scene. And I'm just going to kind of rotate this so that it kind of illuminates this wall. And moving the directional lights around in the scene, only their relative angle is important, because they're just going to illuminate everything in the scene regardless. So we want this to be in the inspector, a directional light. We can change the color to be a bit more goldish. It's maybe a bit too much. Change the intensity, of course. We don't want it to be that strong. And specify shadows. I'm going to do soft shadows. And we're only going to use this this light for baking the scene, the global illumination. So it won't actually be on during gameplay. It'll just kind of, these qualities of lighting will be baked into the scene. So we can change the shadow softness if you like. And everything else, light mapping, this is what we're going to talk about next. We can set it to baked only now, but it's not going to change anything yet. Okay, so important thing is just making sure it kind of gives a quality to the scene that you find attractive. And you may find it necessary, like I know this is going to be a bit dark in here. You may want to add some point lights to kind of illuminate these areas as well. But I'm just going to skip that for now. Okay, so now with that ready in place, I'm going to go to Window, Light Mapping. So that'll bring up this light mapping dialog box. And I was going to drag this directional light into my lights empty game component there. And here I have access to the same parameters. I can change the intensity of this light. And this is, again, this is the only light in the scene. And I could also, basically try to match the angle of the sun if I cared enough. Maybe I could rotate it a bit more. But it's close enough for this. Okay, so I can increase the number of shadow samples. That will give more accurate samples, but it will also take longer to bake the scene. Baking the scene does take some time. In this case, it'll probably take my slow computer about 10 minutes to do that, so I'll just pause the video. But one thing I need to change before I applied or before I bake this light map onto this geometry, I need to change a bit the import settings for this model. If I go to all models in my favorites, select Carpenter Center, and get the inspector the import settings for the model. So scale factor is 1, compression's off, it's read-write enabled. Optimize probably doesn't matter. We want to first generate colliders. That doesn't have anything to do with light mapping, but that will make sure that our character doesn't fall through the scene, that everything has a physical collision event when you run into the geometry. We don't need to swap UVs, but we do need to generate light map UVs. These parameters I don't really change. We have the option to import the normals, which we do want to import the normals. I wouldn't trust Unity's calculate normals. We were very specific in the Rhino model to specify which direction normals were going, so we're going to leave it like that. And split tangents, we don't need to change that. We're going to import the materials, and the rest of this is fine. So then we just need to make sure to apply these settings. And if we don't, we need to make sure to do that before we run the light mapping, otherwise we'll get some mistakes in the results. And I forgot one important step as well. We need to tag this model as static. So if we click on the entire Carpenter Center, so again this is all nested within this one object, and we click on static, yes, change children, so basically all of these components become static. So they receive a flag that is referred to as a static flag. And what that means is that we can apply light mapping, we can bake light maps onto these objects. If they're not marked as static or flagged as static, then Unity thinks that they're moving objects or potentially moving objects and will not allow you to light map them. These we can light map even if we decide to go and change, for example, make a door operable, openable. That's not really going to affect the global illumination much, so we can just lie to Unity and say everything's going to be static, and now we can see the resolution. So basically these subdivisions. So this is how detailed the light mapping is going to be, which should be fine for this case. So the quality is high. Bounces we can set more than one, but it'll take much longer. Skylight color and skylight intensity. This is important to change. If you don't add any intensity to the skylight, then you won't get any global illumination. This is between 0 and 1. I think something like 0.6 or 0.7. We should get pretty good results. And then ambient occlusion also needs to be set higher than 0 in order to get any results. So ambient occlusion refers to basically for each one of these texels in this resolution, looking at how exposed that texel is. So it's essentially how much ambient light would it receive. And we need to set that to 1, or you could set it to a lesser factor and it would have less of an impact. But if it's at 0, then this entire light mapping process is not going to do anything. We also have a maximum distance for occluding rays. If we set this to 0, then we just have infinitely long rays, so it will calculate the entire scene, which is good. That's what we want. And contrast at 1 should be fine. So again, these parameters, skylight color we can change to be a little bit darker, because kind of matching the skybox. Skylight intensity at 0.7, ambient occlusion at 1, and max distance at 0. So that's about all the parameters I need. Then if I go ahead and click Bake Scene, it will export to Beast. Beast is kind of an integrated software that does this light mapping calculation. And you'll see a progress bar down here. This might take some time, so I'm just going to pause. Okay, so now the light mapping process is finished. It took more than 10 minutes, but the results are pretty decent. You can turn light maps off and on. You can see it's a pretty significant difference. If I were to run this again, I would probably lower the strength of the directional light. It seems a bit strong for a kind of a dust scene. It's a bit overblown, but that's alright. I'm just going to go with this for now. But in the future, if I were to do this again, I would just lower the intensity of the directional light. Okay, so we're done with light mapping, and we can proceed to adding in some additional lights just to enhance the scene. Maybe look at these dark areas, see if we can put some lights in there, and have a more kind of slightly convincing result. So as kind of a quick last step for lighting, I'm going to add in um, a couple more lights into the scene that will not be they will not influence the light mapping that we've already done, but they will just kind of be accent lights, additions on top of that light mapping. So if you go to Game Object, Create Other, let's start with a point light. And a point light, so it's just made it at the origin, and we can move it. I'm going to move it kind of inside this dark area here, just to illuminate that a little bit. And point lights will not create shadows. They are also not constrained by physical geometry, so essentially the light appears to shine through walls. But that's fine. I just want to kind of have an overall brightness inside of here, or just add a little bit of brightness. So the light parameters, it's set to point. I want the range, it's now a 10-meter range, but I kind of want to brighten up all of this inside, so I'm going to change that to maybe 40 or 50 meters, which is drastically brighten the scene. I can lower the intensity there, and I'm going to move it inside of this kind of hallway. Maybe make the range more like 70. And I'm going to put that in my light tree. So if I turn that off or on, I can see the impact that it's having. Pretty good. I'll lower it a little bit more. So again, there are no shadows being generated here. This is just kind of an overall cheat for illuminating a dark area. So that's fine. I'll leave that as it is. And then I'm also going to put in maybe a spotlight to maybe illuminate one of these rooms down here. So if I go to Game Object, Create Other, Spotlight, and I'm just going to move that to this area here. I'm going to give it a wider angle, and the range, basically the length of the spotlight, I'm going to lower it to something like 4, and turn up the intensity a bit. So unlike point light, spotlight will be bound by the local geometry. It will not go through walls. However, it also will not create shadows in runtime. So you can see like how it's illuminating all this area, but it's not kind of creating this shadow for this column. So to be used appropriately. In this case, it can give us some interesting lighting effects though. And we can change the color, be a bit more golden, and rotate the angle. So we'll just leave that as it is, and I think that's enough to kind of grasp the basic concepts of lighting. We're now ready to kind of explore the scene a bit, see if there's anything else we need to change. When I do preview, I usually maximize on play just to get the full screen. And if we've done everything correctly, we get something like this. We can explore and navigate the scene. The textures are looking fairly good. And we can of course go up the ramp and see how this. All right, not perfect, but good enough. So as a very important conclusion to all this, we're going to build and run the the game file. So basically taking this out of Unity and putting it into a format where other people can experience it, which is ultimately the point of all this, I guess. So if we go to File, and then we can go to Build Settings. So Scenes and Build, it's important that we need to add the current scene, which is just called Night. That turned out to be not totally night-like, but and then none of this is super important. You can, of course, you can build for specifically, in Unity makes it quite easy to build specifically for a number of different platforms. Not all of these are available with every license of Unity, so it depends on what you have. In this case, I'm just going to build for a web player as opposed to an exe or an app. I think web is probably the most versatile format and increasingly common format. So I'll just go ahead and do that, add the current scene, and build and run. So this will take a little while to build. You'll need to select a folder to where it will build to. So I'll just make a new folder here. And it will compile all of the assets dealing with all this folder structure, and will ultimately compile everything into an HTML file, which will basically give instructions using jQuery for how to reference the Unity file, which it will also create. And that's all that you need to sort of put this kind of immersive environment on, for example, a portfolio website or any other website you might have. So while that's processing, this is the kind of HTML file that you'll get. So it's just a matter of referencing this in your content management system that you're using. And then it will create a build that looks something like this. So you can edit, of course, the titles and everything in the HTML or in the CSS. That's it's a fully navigable environment now. It takes a little while to load the website or load this environment into the website, depending on how much geometry you have. And of course, it can always be optimized, but it seems pretty appropriate for what we have here. So that's it. Hope you got something out of this, and yeah, thanks a lot.